Consider the differential equation y double prime plus p of x, y prime plus q of x, y equal to 0. And suppose that a non-zero solution y1 of x is known for this second order linear homogeneous equation. To find a second solution, assume that the second solution y2 of x is equal to a function v of x times y1 of x, where this function v of x is an unknown function. Note that if v of x is non-constant, then y1 of x and y2 of x are not constant multiples, right? Because this is non-constant. This provides some intuition for choosing the form of y2 of x. And that intuition is just the fact that y2 and y1 are going to be linearly independent, and therefore, there are two fundamental solutions for this equation. Again, this is the format we're assuming for the unknown y2, knowing the y1 and not knowing v. So what are we supposed to do next? We're supposed to make sure that this y2 satisfies the original equation by taking first derivative and second derivative and put the function first derivative and second derivative, plugging it in to the equation. Taking derivatives of y2 gives us y2 prime byproduct rule is equal to v prime y1 plus v times y1 prime. And then second derivative of y2 double prime is going to be by two product rules of the two terms of y2 prime is going to be equal to v double prime y1 plus 2 v prime y1 prime plus v y1 double prime. Now plugging in y2 prime and y2 double prime into the original equation gives us this formula: v double prime y1 plus 2v prime y1 prime plus v y1 double prime plus p of x times quantity v prime y1 plus v times y1 prime plus q of x times v y1, which is the original y2. And here, this quantity together is y2 double prime, and this quantity together is y2 prime, and this part is y2, so it's y2 double prime plus p of x times y2 prime plus q of x times y2 equal to 0. Let's reorder this equation in terms of v, and it becomes this equation, which is v double prime is going to be its own term times v1 plus a term for v prime, which is v prime times quantity 2y1 prime plus py1, plus another term that is for v, and that's v times quantity y1 double prime plus p y1 prime plus q y1, and this entire thing equal to 0. I want you to notice that this part with a brace underneath is just plugging in y1 into the original linear second order equation, which is going to result in 0 because that equation was homogeneous. That being 0, you end up with this equation: v double prime y1 plus v prime times quantity 2y1 prime plus p y1 equal to 0. So the equation becomes w prime y1 plus w times quantity 2y1 prime plus p times y1, parentheses closed, equal to 0. This is a linear equation for w, and it's a first order linear equation. Incidentally, it can be solved both using linear equations or separable equations. So we're going to solve it in terms of separable equations, which is going to give us w prime over w is equal to negative 2y1 prime over y1 plus p. Take the integral of both sides, and you will end up with natural log of absolute value of w is equal to minus 2 natural log of y1, absolute value of y1, minus the integral of p dx plus c. The rest is just computation. Exponentiate both sides of that equation, and you get e to the power. The right side of that equation is equal to e to the power the left side of that equation. And that, after simplification, gives you w is equal to c times e to the power negative integral of p over y1 to power 2. And then w is equal to v prime, so substitute that in that equation and integrate to find v. And so in this case, v is going to be equal to the integral of that e to the power negative integral of p, the entire thing over y1 to power 2, and integral is with respect to x. Now, what was y2 and why did we need v? Y2 was in the form v times y1, so that the last thing that we do is we write it that way. We write y2 is equal to y1 times that integral that was mentioned. And this is the formula that we find and we use for reduction of order.